Good afternoon, everybody. I am Dr. P.K. Parhi from Central University of Jharkhand, Ranchi. I have worked more than 15 years in Water Resource Department, Odisha. I have worked in field in managing water in irrigated canals, and later I shifted to teaching. Now I will give some solutions to how to manage water needs in irrigated agriculture. Now, everybody knows the irrigation, we cannot compromise with irrigation. We have to depend on irrigation because irrigation is needed to provide food and fiber for the survival of all the population living in this earth. But due to rise in population, we are facing lot of problems, and it has been estimated by FAO, global agricultural production we have to grow by 60% by 2050 to meet the increasing food demands. And by 2030, agricultural water use will be increasing by 14%. And worldwide, 60% of global population will suffer from severe water scarcity by 2030. This is the prediction by FAO. This is all about your world situation, but when we go for considering the situation in India, and everybody knows 16% of world's human population and 10% of world's cattle population are available in India. But India have 2% of world's land area and 4% of world's fresh water. And per capita availability of land, it was 50 years ago, it was 0.9 hectare per capita, but it has been projected by 2050, the per capita availability of land will be 0.14 hectare. Out of total cultivated area available in India, presently 37% is irrigated, which produces 55% of food requirement. But the population of India is expected to stabilize at around 2050 at a population of nearly 164 crores. Again, the water requirement will be around 1450 billion cubic meter per year by 2050. That is another thing. Gross per capita availability, which was 1820 cubic meter in 2001, it will decline to 1140 cubic meter in 2050. That is the main reason we must go for managing irrigation water management. In view of the above, we have to go to maximize crop yield per unit area of irrigated land per unit time per unit volume of water applied. But it is presently, we are having global irrigation efficiency of around 40%. It means there is a lot of scope to increase the global irrigation efficiency so that the water availability can be managed to meet the irrigation demand. And I am giving some suggestions which everybody knows or everybody must try to implement in the field so that the water scarcity can be reduced to a appreciable extent. Now, first method is reducing losses which are not used by plants for productive purposes. We must try to reduce the losses which are not used by plants for productive purposes. This one of the methods in this category are canal lining. Everybody knows canal lining now we are practicing in the fields, and this can reduce up to seepage loss up to about 95%. This is some of the pictures I have collected in the field. Another method is micro irrigation. This everybody knows. Micro irrigation can reduce the losses. Now another method is scientific irrigation scheduling. Irrigation scheduling, everybody knows, and we must go to apply optimum quantity of water at the most appropriate time, so that crop stress can be avoided and water losses can also be avoided. It reduces consumptive use primarily because of the improved timing of water applications. Now, another is implementing managed deficit irrigation. Another important thing is improving irrigation system through modernization of infrastructure. Modernization of infrastructure means modernization of water delivery system. It means to reduce wastage and to make cost-effective operation. Another method is weed control. Weeds are major non-beneficial consumers of water, and this has to be minimized by using suitable methods. Another thing is introducing site-specific crops, and it is experienced by everybody. We are using paddy where water scarcity is there. Everybody knows paddy consumes lot of water, and sugarcane consumes lot of water. But we are still, as our crop habits, we are doing that, and we must take care to introduce site-specific crops. Crops that mature quickly, small grain crops, deep-rooted crops, and drop-resistant crops. These crops maximize use of precipitation water stored in the soil for long time. However, long season crops such as maize may have reduced yield. Okay. Next is your site-specific irrigation. Use of site-specific irrigation technology. Where to go for canal or where to go for drip irrigation or sprinkler irrigation, that has to be decided. And another thing is maximizing crop evapotranspiration. Crop evapotranspiration everybody knows, and crop evapotranspiration it is to be minimized. Maximizing means it will consume more water. Minimizing means it will consume less water. And daily ET can be reduced by 5 to 10%. This is also leads to a lot of wastage. And how it can be done? It can be done on application of anti-transparent materials. And stomata closing type chemicals such as reflecting materials come in the category of anti-transparent materials. Another management strategy is reduction of demand for irrigated production through substitution. Through substitution means it is use of rain-fed agriculture, growing less water consuming crops in low water available spaces. We must go for using those crops which consume less water, and growing more water consuming crops in more water available areas. It means we must go for site-specific crops. And another thing is use of genetic approaches. Genetic approaches means genetic approaches raise water productivity on selection of crop varieties. We must use certain types of crops which uses less water, such as drought resistant crops, short growing seasons, earlier flowering type crops. And one more thing, we cannot stick to a specific type of technology or theory to increase water use efficiency. But what we have to do? We have to go for system level of optimization. It means maximization of water productivity is possible considering all the terms, all the parameters what we have discussed, so that the yield is optimized with minimum use of water. That has to be taken care of. But with all these things, the irrigated agriculture has to be made economically and environmentally sustainable through all these approaches. We cannot go for using any technology for our beneficial use, but whatever technology or whatever methods we are using, it must be environmentally sustainable. that must be taken care of. And why? This is due to the fact that society cannot afford to lose dependence for food, fiber, and fuel production from irrigated agriculture. Thank you.